complicated solution. I think you agree with me there that to extract the phase as well, and not the model becomes really complicated with a lot of parameters and additional correlations to be trained. But what is it then in terms of performance? We did that exercise with the extended, so the complicated solution, and our spatial temporal beamformer to extract not only the frequencies but also the phases. And then you see the typical plot here, the accuracy as a function of epoch length. You see that the spatial temporal beamformer is performing better. You get a quicker, a higher accuracy. And this is what counts, this is what matters. So you get about at half a second, you do well already in terms of the performance. And this is something that we encountered in some earlier where we were doing the sample sinusoidal case. There we knew already that we could get a very nice performance already at half a second recording length. So this is then can be taken up in a Speller device, and then you can do some actual interfacing. So some take-home message about all this SSVP or the FFEP. You have to consider stimulation of 6 Hz. You have to exclude the alpha range preferably, because that's common to all your recordings. You have to probably account for subject dependency of the best frequencies. Some subjects have better responses in particular frequency ranges than others. And if you want a simple solution, you can take the dividers of the screen refreshing rate. This is the simplest way of working, but we have learned by now that you can get rid of that restriction and by adopting the sample sinusoidal stimulation case. Okay, so there is also some the previous plots, so when we were looking at performances, we were indicating also the bipolar case. So yeah, the actual there is an influence of the actual electrode setup. You can have, as you know, a central reference, mastoid based reference, bipolar referencing, and so on. So the choice of that does have an influence as well in resolving the peaks in your spectrum. So that could be a point of consideration. An important figure is this one here about the signal-noise ratio. How about that? Let's look first at the amplitude. So these are the frequency stimulation. Then the amplitude of your response looks a bit like that. So yeah, it increases a bit, but then it's sort of 1/f function. Yeah, the amplitude goes down as a function of stimulation frequency, and indeed the limitation is stretching here. So limitation is about, people usually cut the EEG spectrum before the 50 Hertz power line, although you can record further EEG beyond 40 Hertz or so. You can go further, and some people say that you can go up to 90 Hertz and beyond. If you know what you're looking for, you can go further than beyond and go into the so-called gamma band and record responses there. It's not easy to get results there. There are some examples of that when you go up to 70, 80, 90 Hertz, because you'll have a lot of muscular artifacts in that frequency band that corrupt your signal. And but yeah, if you also know how they look like, these signatures, you can account for it and so on. You feel it coming. So it depends on how complicated and how much you can account for. It will determine if you're able to resolve anything in that high frequency band. So usually people stay away from that unless you have good reason not to. Importantly, the signal noise ratio, we just saw the amplitude, the signal noise ratio is more or less the same. You see the signal noise ratio is a few dB, decibel, 2-3 dB is not a lot, but it's more or less constant over the frequency range that we have been talking about. Even though the amplitude goes down, the noise also goes down with the same kind of plot, same kind of 1/f function, and this way you are not so bothered then. Actually, you can place your stimuli wherever you want. The signal noise ratio will be more or less the same, but you have to know that the amplitude will be affected, but not so much the signal noise ratio. That's a bit of good news. But anyway, the selection of the frequency range is subject to careful consideration. Okay, maybe the last video. This is, if it works, hopefully. What's happening? Why is it not playing? Crap. Why is it not playing? Okay, let me see where it was. I played by hand. Which one was it? Hello, just this one. Yeah, it was this one. So I hope you can see it. So you have characters here grouped in quadrants on the screen, and you pay attention to one of the quadrants. You have selected it. The characters are redistributed into new quadrants, and the process repeats. You focus on one of them, you select that quadrant. These characters now are matching one-to-one the four quadrants, and this way you can type character per character. So this is how you can have a mind speller based on SSVP. Okay, so I think I will stop here, and thank you for your attention, and I hope to see you next week. Okay, bye-bye.